Hi Afia, how are you?
Hi, ma'am.
Okay, so I said just now to LF that we'll be taking a few examples from cubic polynomial and then we will start the first chapter. So suppose we are having x cube minus 4x square minus 7x plus 10. Okay, now we are going to factorize it. For factorizing cubic polynomial, the method which I was discussing in the last class, let's repeat that. We will try finding that x value which can make this complete polynomial 0. Okay, so maybe we will be checking with x as a 1, x as a minus 1, x as a 2, x as a minus 2. Maximum this one. If we want, we can also check with 3 and minus 3, but not more than that. Okay, so x as a 1, if I will drop at the place of x, you can see 1 we will be getting here, minus 4 we will be getting here, minus 7 we will be getting here, plus 10 will be getting here. Now let's see, are we going to get 0 or not? So 1 minus 4 is minus 3, minus 7 plus 10. Can you see we are going to get 0? So x equals to 1 I have taken. I had taken x equals to 1, positive 1 I have taken. Okay, that's why I was not worried with the sign or anything. That means x minus 1 is the factor. This one is making sense, Aleph and Afia?
Yes, ma'am.
Now we will be writing x minus 1, x minus 1, x minus 1 three times because it's cubic. Now we will try doing the arrangement. So first term is x cube. Okay, in front of the first bracket, what shall we write to create x cube? The first term. Afia,
Yes, ma'am.
what shall I write over here in the box?
X square.
X square. Now this x square will multiply with x, will give us x cube, which we want. Okay, but automatically it will give us another term also. Okay, which we have not asked for, but okay, distributive property will give us. That means minus x square also we are going to get from here. Now we will go in the rough part and we will ask minus x square, minus x square. Okay, we are having in hand and we need minus 4x square. If I will ask you, LF, what can be taken in the second box? Can you tell me? Yes. Afia?
Just for X.
What x?
For X.
See, you want to create 4x square, but already we are having minus x square in hand. Can you see?
Yes, ma'am.
So can we say only minus 3x square is needed now?
Yes.
Yes, ma'am.
Okay, so instead of 4x, can I write minus 3x?
Yes.
Are you getting it, LF?
Yes,
Yes,
ma'am.
ma'am.
Okay, but we ended up getting minus 3x square plus 3x. Okay, minus 3x square we got. Okay, which added together will create minus 4x square. But we also got one extra term, that is plus 3x. And now the next term is minus 7x. Can you see? So plus 3, what shall we do with plus 3? See, you should write in the rough part like this. Plus 3x, and what shall you do over here? To get minus 7x. Minus 7x. Can we say we need to take minus 10x? Yes or no?
Yes, ma'am.
Are you getting LF?
Yes, ma'am.
Okay, little bit of understanding is required. So here we will write in the next box minus 10x. Okay, minus 10x. Then auto not 10x. 10x is required. X is already there. Minus 10 only. Okay, just minus 10. And then you will find that automatically the next term is getting managed by itself. Are you getting it?
Yes, ma'am.
Okay, and we are done.
Yes, ma'am.
Okay, we are done. We are having in one bracket x minus 1, in another bracket x square minus 3x minus 10, which can be done. Okay, splitting the middle term we can do again for the second bracket. And yeah, we need to do it. We can do and we need to do it. Please do it. No, x square minus 3x minus 10. Please factorize it by splitting the middle term. Afia and LF. Please do the circled one by splitting the middle term. Factorization.
We split the middle term, and I think we'll take the factors as minus 5 and plus 2.
Yeah, we will be taking, okay, 5
Minus
and
plus 2, right?
5 plus 2. Yes. LF, what are you getting?
Same answer, ma'am.
Okay, x minus 5, x plus 2, right?
Yes, ma'am.
Okay. So yes, we are done. Okay, now I'll be starting with the first chapter. If you still not that confident with cubic one, don't worry. This is completely new, completely different. I'll regular basis I will keep on taking few questions so that you can feel confident and you will start doing okay all the steps by yourself. Now this type of question is not that important. Cubic one is not that important. Okay, the splitting the middle term is really important. Cubic one is not that important, but yeah, in your book you are having, so you should be prepared. In exam it can come. So yes, on regular basis we will be taking questions from here. Now let's start with the first chapter. Number system we are having as a first chapter, right?
Yes, ma'am.
Already in your previous class you have learned about rational numbers, right?
Yes, ma'am.
Okay, let's continue. So if we are having, suppose number system, here we will be talking about real numbers. Real numbers, all those numbers which exist in this universe, okay, those are real numbers. Any number, till now you have encountered any number, Okay, I'm telling you everything is called real number. So real number means all the number, even number, odd number, prime number. Okay, every number, all the numbers. Okay, natural number, whole number, rational number, and here you will be learning irrational number. Everything is real number. Okay, any number. Okay, I will close my eye and write any number on the screen, that is real number. So you can understand real number means just any number, that's called real number, which exists in real life, that's called real number. So real number we are going to discuss over here. In real number are having two categories. One is rational number, another is irrational number. Rational number you have learned in the previous class. Properties related to rational number and everything you have learned in the previous class as well. Here also I am concluding that if you are having, okay, the diagram looks like this actually. That if we are having on, first we are having natural number. Can you tell me what is natural number?
All the counting numbers starting from 1 to infinity.
Okay, yes, 1, 2, 3, 4, all the counting number are natural number. What are whole number?
Starting from 0.
Start
Yes,
from
number
0.
starts from 0, 1, 2, 3, 4. These are, okay, whole number. Yes. And if I will say all natural numbers are whole number, is it true, Aleph?
Yes.
No, ma'am.
All natural numbers are whole.
No, ma'am. No, ma'am. It's
If
all whole numbers are natural numbers like that.
all whole are natural. 0 is a whole, but 0 is
No,
natural.
I mean, yeah, it is correct.
Okay, this one is correct. Okay, all natural. Like whatever natural numbers we are having, everything 1, 2, 3, 4, it starts from 1, and we can say everything is whole number. All natural are whole. Whenever this type of question will be there, you can just think about it in this manner also, that all natural number comes inside. By yourself you can write comes inside. I will show you a Venn diagram. Now only I will show you this type of diagram or oval shape, circles, like so many different circles I'll be drawing, not circle, oval shape I'll be drawing. Okay, which will help you identifying whether the statement is true or false. I am coming to that part. Let me first draw the complete figure. So first natural, then whole number, then integers. What are integers?
Integers are like all the numbers, including negative and positive and 0.
Yes. Yes, right, Aleph. Integers are the number which has 0. Positive number, that means +1, +2, +3, these numbers, and the negative numbers as well, -1, -2, -3, till infinity, right?
Yes, ma'am.
Okay, after that we are having rational numbers, which we represent natural number by capital N. We represent whole number by capital W. We represent integer by Z. Okay, and we represent a rational number by capital Q. Okay, so rational number means all these numbers. Natural numbers are rational, whole numbers are rational, integers are rational. Okay, any number, you have learned the definition, any number which is in the form of P by Q, where Q is not 0, are rational, right?
Yes, ma'am.
Yes, ma'am.
Okay, now we are having irrational numbers also. Just a moment. Yeah, let's continue. So we are saying all these numbers, okay? Natural number, whole number, integer, all these are rational number, and you know that, right? Afia and Aleph.
Yes,
Yes,
ma'am.
ma'am.
Okay, now irrational number. Irrational numbers, okay, are just aloof. Over here, I will draw a circle, and here I will write irrational. Okay, irrational numbers. So you can see irrational number is completely different. I am coming to the example that which type of number we are going to call irrational. And now a bigger circle, I will be drawing a huge bigger circle containing all this and irrational also. That is called real number. Okay, that is called real number. So are you understanding what is real number? Everything. We represent real number by capital R. Is it clear so far?
Yes, ma'am.
Okay, now let's discuss which type of numbers are irrational number. So basically decimal numbers are of two type. Okay, when we are talking about any decimal number, we can think about two types of decimal number. Okay, one is terminating decimal. Let me write it first. Decimal numbers are of two type. One is terminating decimal, another is non-terminating decimal number. Terminating means you must have seen in any of the show termination round is going on or the person got terminated. Termination means in English it means stoppage is there. Okay, something got stopped. That's called termination. So when we are talking about terminating decimal number, suppose I have written 2 by 5, and if we will convert it in decimal, we will be getting 5 4 times 20. Okay, so 0.4. Yes or no?
Yes, ma'am.
Are you getting it, Aleph? That 2 by 5 can be written as 0.4.
Yes, ma'am.
Yes,
Okay, so previously we were having a fractional number, okay, which is a rational number, and we converted it in form of decimal, and which is terminating decimal. Why terminating? Because after decimal, few digits will be there, and then our division will stop. The remainder will be completely zero. Okay, for example, if we are having suppose 23 by 4, let's do the division. We will divide 23 by 4. We'll be having 4 5 times 20. Okay, let me check whether it is then we'll be having 4 6 times 24. 4 sevens are 28. 7 times 28. And then we'll be having 4 5 times 20. So our answer, we have taken a fractional number. In P by Q form, we have taken a number and we understand it is rational. Okay, which we have converted in the form of decimal, and we got 5.75, which is again a terminating decimal. Why we are calling it terminating? Because after decimal 7 is there, then 5 is there, then there is a stoppage. Decimal okay, our division got stopped. Division got, okay, at the end we ended up getting the remainder as a 0. Okay, so 5.75 we are having here. There is a stoppage. So if you are thinking what are the example where there will be no stoppage, so let me show you such examples as well. Suppose you are having 10 by 3 and you are doing the division. So you are dividing 10 by a number 3. You will be having 3 times 9, right? Right?
yes, ma'am.
Okay, some of the students says me that they don't know why I'm writing 3 over there. So let me write a quotient over here. 3 times 9, remainder is 1. If you will give the decimal, you will be getting 10 again. Again 3 times 9. Again you got 10. Again 3 times 9. So are you understanding here the division is not getting stopped?
Yes, ma'am.
Yes, ma'am.
How many time? Infinite time. Okay, this is the example of non-terminating decimal number. Termination means stoppage. So after decimal, 2 digit, 3 digit, 4 digit, 5 digit, 6 digit, 10 digit, but your division will stop. In the other example, like 10 by 3, your division will never ever stop. That's called non-terminating decimal number. Getting it?
Yes,
Yes,
ma'am.
ma'am.
Okay. So let me write it. Decimal numbers are of two types. One is terminating decimal, which we are getting from rational number. You can see the example. We are getting this terminating decimal number from where? From the fraction. Which type of fraction? It's rational. Once we are saying fraction means rational, right? Another is non-terminating decimal number where our decimal will not stop. Okay, our decimal will not stop. For example, we'll be having 10 by 3, and you just now you have seen it was giving us 3.333333333333. Here also, okay, we have taken 10 by 3, a rational number, and we converted in the form of decimal, and what we got, 3.3 bar also we can write it. Are you getting it?
Yes, ma'am.
Yes, ma'am.
Okay, so rational number can be terminating, rational number can be non-terminating. Okay, now all of sudden, if I will just give you one example, that 2.75833972, is it rational or irrational? So you will say that since there is a stoppage, at least after how many digit decimal is there, then 1 2 3 4 5 6 7 digit we are having, and then we don't have any other number. So after 7 digit there is a stoppage. That means it falls in the category of terminating decimal number. And terminating decimal number means rational number. Are you getting it?
Yes, ma'am.
Okay. If I will write from now onward that 2.75, 75, 75, 75, 75, like this. Or maybe I will give you
It's
2.7.
not terminating.
Okay. So you will say it falls in the category of non-terminating. But I am coming to the part that here repetition is there. Proper, you can see a beautiful repetition, 7575757, 2 digit repeating itself, 7 and 5, 2 digit repeating itself. Okay, so this is falling in the category of non-terminating repeating, which we also call as a recurring decimal, and this is also rational. Is it clear so far?
Yes, ma'am.
Okay, now which is not rational, I am coming to that part as well. So when you will be having example, just a moment. Sometime, okay, in your previous class, you have learned the concept of square root and cube root. Okay, there only you will find that if you are taking root 2, root 3, root 5, all those numbers which are not perfect square number, which just got stuck inside the square root sign or root sign. Okay, when we will calculate by long division method, when you will sit and calculate, okay, our whole life will pass, but this numbers root we won't be able to find. Okay, why? Because it will keep on coming. We will be having 1.41, 4, 2, 3, 5, 7, 9, 5, 2, 9, 3, 1, 5. It will just keep on coming and keep on coming and keep on coming and keep on coming. Numbers will keep on coming. It will never ever stop. Okay, and you won't be able to find any proper pattern, any proper repetition will not be there. Can you see?
Yes, ma'am.
These type of numbers falls in the category of irrational number. That's why we say that root 2 is irrational. So from now onward, we will be saying if the number is non-terminating, if the decimal number is non-terminating and non-repeating, Non-repeating means no proper pattern we are able to see over here. That is called irrational. And which type of number will start behaving like this? Square root number, which is not a perfect square number. If you are having root 36, you will be able to take out 6 from there. If you will be having root 4, answer will be only 2. But if you are having root 2, root 3, root 5, okay, root 6, root 7, all this root number, okay, which you are trying to take it out from the root sign, but you are not able. And anyhow, you have to use long division method and you have to take the decimal, will start behaving like non-terminating, non-repeating decimal number. And these are irrational. Is it crystal clear?
Yes, ma'am.
Okay, if you will try calculating the answer in your calculator, then your calculator also has a capacity. Only 6 digit you will be able to see the answer, only 7 digit. Okay, so that is the capacity of your calculator. Okay, just by looking at the answer in the calculator, we cannot say that root 2 is terminating. The calculator is giving us the answer according to its own capacity. If we will use supercomputer, then supercomputer will also show answer according to its capacity, but the number will keep on coming till infinity and no proper repetition will be there. Pi is also irrational. Pi is also irrational. But if you have used pi value as a 22 by 7 for calculation in your previous class, so this is approximately we use for calculation purpose only. Actually, pi is irrational. When you will see on Google, okay, Google, tell me what is the value of pi. So Google will say that pi is 3.1415927185231 okay, 1874. Any random number will keep on coming, will keep on coming, and keep on coming, and keep on coming, and keep on coming without any proper repetition. Okay, pi is an irrational. Is it clear?
Yes, ma'am.
Okay, so all these numbers from now onward we will keep in mind that decimal numbers, when we are having terminating decimal, that is falling in the category of rational number. When we are having non-terminating, but repeating decimal, that is falling in the category of rational. When we are having non-terminating, non-repeating, that is falling in the category of irrational. Okay, so let's continue and let's answer a few questions, true false based question. Okay, then we will be proceeding with the next part. Just a second. I'm sharing the screen where we are having questions from the book. Question number 4 over here. Every natural number is a whole number. True or false?
True.
LF, is it true or false? Every natural is whole.
True.
Yeah. Okay, we can see natural is coming inside the whole. Natural is coming inside the whole. So yeah, every natural is whole. Next, every integer is a whole.
False.
Yes, LF, is it true or
False.
false? Okay, it is false because integer does not come inside the whole. Okay, we are having whole, we are having natural, we are having then integer. Okay, so every integer is whole. We cannot say integer is not coming inside whole. It must come inside the whole in this diagram. Okay, you can think about any example that -2 is integer, but this is not whole. Okay, let's move. Every rational number is a whole number.
False.
False.
Okay, every rational number is not whole. Rational number means p by q form. Okay, rational number means p by q. Rational number can be this one, rational number can be this one, rational number can be this one, rational number can be 0, rational number can be 5. It can be whole or may not be whole. Okay, so all are not whole. It is false. Clear?
Yes, ma'am.
Do few example based question as well. Every whole number is a natural number. Every whole is natural. True or false? Every whole is natural.
False.
LF, is it true or false?
Ma'am, can you pardon?
Yeah. I said every whole is natural.
No, ma'am.
Why?
Because like whole number has 0 and natural number don't have 0.
Yeah, correct. Next, every integer is rational.
Yes, ma'am.
Yes, right, Afia?
True.
It's true.
Ma'am.
All integer are rational.
Yes, ma'am.
Yeah. Okay. All integer comes inside rational. Every rational is an integer.
False.
Okay. Every rational is not integer. So far, any confusion? No. Let's move. Now we will see how to find, suppose we are having two. Just a moment, let me take the question. Suppose we are having 3 and 4. We have to find 6 rational number in between these two numbers. 6 rational number in between these two numbers. We have to find 6 rational between 3 and 4. Okay, let's find it. So whenever we are having such question where you are given two numbers and in between that you have to find rational. Rational means we understand any number which is in the form of p by q. Okay, that's called rational. Integers are rational, Okay, whole are rational, natural numbers are rational. This much understanding, okay, so far you have developed. Now in between 3 and 4 we have to write 6 rational numbers. So here in this type of question there is a easier way. In your previous class you have learned maybe, okay, finding rational between the given two numbers, okay, but here there is a short trick as well. The short trick says that if you want to find six rational number in between 3 and 4, okay, what you can do, you can multiply 6 plus 1, that is 7, at least 7. Okay, you can take bigger number as well, that means 8, 9, 10, 11, 12, anything you can take, but at least you should take 7. Okay, you should take 7 and you should multiply it in the numerator and denominator of this given number. Okay, so 3 we are having, 3 can be taken as 3 by 1. Okay, we can write this 3 by 1 as a 3 into 7 by 1 into 7. That means 3 can be written as 21 by 7. Are you getting it, Afia and Aleph? No. In mathematics, whenever you are having a fraction, that is 5 by 7. And if you are multiplying the same number in the numerator and denominator, that means 5 into 2 by 7 into 2, and it became 10 by 14. That means you have not done any change. Okay, 5 by 7 and 10 by 14 is the same thing. It's an equivalent fraction. Can you see that? 2 5 times 10, 2 7 times 14. Yes or no?
I get it now.
Okay, so when I am saying that you are having a fraction and in numerator and denominator you are multiplying the same number, that way you are not changing the fraction, you are just doing one arrangement. That recall in your previous class when you started learning the concept of fraction. Okay, there you learned that in a fraction, when we divide the numerator and denominator by a same number, or we multiply the numerator and denominator by a same number, we don't change the fraction. Okay, it is the same fraction. Suppose we are having 1 by 3 and I am multiplying in numerator 5 and denominator also I am multiplying 5 and writing it as a 5 by 15. These two are same fraction, yes or no? Aleph, is it same?
Yes, ma'am.
Aleph,
Yes, ma'am.
can you see 1 by 3 and 5 by 15 are same?
Yes, ma'am.
Why it is same? Can you tell me?
We can simplify the 5 by 15 like by like 3.
Cancellation, and we will
I
get,
mean 5, 5, 5.
yeah. Okay. So yes, the same logic. Okay, we can cancel this 2 and we'll be getting again 1 by 3. So when in a fraction you are multiplying same number in the numerator and denominator, or let me add over here divide also. When you will divide, suppose you are having 24 and you are having over here 12, and you are dividing numerator and denominator by the same number. Okay, suppose you are dividing numerator by 3 and dividing denominator by 3. In your rough part you are doing this, you will be getting 8 by 4, right? Right.
Yes,
Right.
ma'am.
Again I am repeating, this one and this one is the same thing. You can cancel both of them and you can check. Okay, you can cancel both of them. 12 1 times 12, 12 2 times 24, 4 1 times 4, 4 2 times 8. You can see both are exactly same. Okay, when you are multiplying or maybe dividing, here we don't need to do the division and all, but just for your understanding I am telling you, we are not disturbing the fraction when we are multiplying or dividing. Addition and subtraction we will not do, that way we are disturbing the fraction. Okay.
Yes, ma'am.
So we were having at first 3, a number 3 and 4, and in between this 3 and 4, okay, if anybody will ask us to write any number, we can write, okay, 3.5, 3.6, 3.1, 3.2, but in p by q form we need to write it, in p by q form. That also we can write. Okay, That also we can write. See, 3.5 we can write as a 35 by 10. But. Okay, here there is a easier way not to go this way. There is another way which is simple, really simple, which says that what we can do, we can make the equivalent fraction for 3 and we can make the equivalent fraction for 4. How? If we need to write 6 numbers, 6 rational, that means 7 we can multiply in numerator and denominator. Here the denominator is 1. So 7 we can multiply here in the numerator and in the denominator. We will be getting 21 by 7. And this 3 by 1 and 21 by 7 is the same thing. So far we have not disturbed. Making sense?
Yes, ma'am.
Similarly, I'm going to change this 4, just the representation. Okay, 4 can be written as 4 into 7 by 1 into 7. That means 28 by 7. Okay, 3 became 21 by 7, 4 became 28 by 7. We have not done any disturbance. Whatever fraction was there, whatever number was there, originally the same number we are having. Okay, my eyes can say that the numbers are different, but my mind will say, don't worry, numbers are same. Go ahead. Making sense?
Yes, ma'am.
Okay, now in between 21 by 7 and 28 by 7, we can write, okay, without thinking about anything, we can write numbers, okay, keeping the denominator same. So 21 by 7, we can write 22 by 7 is the next rational. 23 by 7 is the next rational. 24 by 7 is the next rational. 25 by 7 is the next rational. 26 by 7 is the next rational. And 27 by 7 is the next rational. If you want, you could have multiplied with 8 in numerator and denominator, 9 in numerator and denominator, 10 in numerator and denominator, your wish. But bare minimum, please try multiplying 7, because that way you will be getting 1, 2, 3, 4, 5, 6 rational. If you would have multiplied with 10 or maybe 20, okay, so many, okay, easily you would have written rational numbers. Making sense?
Yes, ma'am.
Aleph, are you getting it?
Yes, ma'am.
Okay, let's proceed. So this is how we will be solving question number 2. Directly like this? Yes, directly like this. Any statement is needed? No. Okay, I'm going to show you question number 3 as well. And let's see from the beginning how you will be writing when you are giving any test or exam. Okay, which way you are supposed to write it. So we are having 3 by 5 and 4 by 5. And in between these two, we need to write 5 rational number. 3 by 5 we are having and 4 by 5 we are having. And we need to write 5 rational number in between these two. So we will 5 rational, that means at least 5 plus 1, that means 6 we will be multiplying. At least 6. Bare minimum 6. You can multiply 7. You can multiply 8. Because you know, if you are multiplying same number in the numerator and denominator, you are not disturbing the fraction. You can multiply anything. Okay. But bare minimum, we will multiply 6. So we will make this 3 by 5 as a 3 into 6 by 5 into 6. And we will be getting 18 by 30. And this one we will be multiplying 4 into 6 by 5 into 6. And we will be getting 24 by 30. Now we are having 18 by 30 and 24 by 30. And in between this, we will be able to write 5 rational very easily. Okay, 18 by 30, next will be 19 by 30. Keeping the denominator same. Okay, we don't have to think about anything now. And this process is that simple that it will take 1 minute to write all these rational. Okay, then 20 by 30, then 21 by 30, then 22 by 30, then 23 by 30,